Welcome to Beyond Belief, where we feature fascinating people with diverse viewpoints, talking together, striving for meaning and integrity. And just before we get started, I'd like to ask you please to hit that subscribe button right down there and stay on top of all the great programming that we have here at Aish. My guest today is Dr. Frank Tipler, who was born in Andalusia, Alabama, a place I'm not familiar with, but it sounds cool. He has a bachelor's of physics from MIT and completed his PhD at the University of Maryland. Dr. Tipler became an associate professor in mathematical physics in 1981 and a full professor in 1987 at Tulane University, where he has been a faculty member ever since. Please welcome to the show, Dr. Frank Tipler. Hello, Doctor.
Hello, I'm glad to be on your show.
Thank you so much for being here. And I want to just jump right in and ask you some deep questions, of which I know you have some fascinating things to say, both about science and theology, and in some ways how they intersect. And I looked on your website and read the following thing, which I thought was interesting. It says about you, it says, all other physicists either apply the known laws of physics to narrowly confined inquiries or outright reject the known physical laws if it conflicts with their distaste for religion. So my questions to you are, is that a common phenomena that scientists just disregard data if it doesn't fit into their worldview? And do you find that that's a common thing, that, you know, that they have a distaste for religion?
Oh, I think it is unfortunately very common. What scientists should do is go with the data, go with the firmly tested laws of physics, and accept whatever consequences there are. But unfortunately, the laws of physics have been showing throughout the 20th century that, my goodness, there was a beginning to time, and we now know from direct measurements about 13.8 billion years ago. And worst of all, at that beginning of time was a supernatural being who created the entire universe out of nothing. I won't use the common word for that supernatural being, but we all know what it is. And physicists, not being stupid, know equally well too. So what did they do when they learned this? Well, they decided laws of physics have to be changed to eliminate that supernatural being in the beginning.
And could you provide our audience with an example of the kind of change you're talking about? How did physicists change the laws of physics to accommodate their preconceived notions?
I'll use the most recent examples that I am familiar with. Stephen Hawking, for example, a brilliant physicist who actually began his career proving that the universe began in an initial singularity. What is initial singularity? A singularity is something intrinsically infinite. In the words of the great cosmologist Fred Hoyle, it's something intrinsically outside the laws of physics, not only the laws of physics that we know, but it is not subject to any conceivable laws of physics, and it determines everything that happens in the universe. Now, if it's outside of space and time, I call it supernatural, because that's what supernatural means, outside of nature. Nature is what is in space and time. Matter, space and time, that is subject to the initial singularity. As I've said, Stephen Hawking began his career proving that if the Einstein equations correctly describe reality, then reality had to begin at an initial singularity. Now, Hawking hated this conclusion. He was a devout atheist. So what he wanted to do was to see if he could modify the laws of physics to get rid of that nasty singularity in the beginning. What he did was to create a universe that we call cyclic universe. That is, once you go through time, time is not linear as it is in the Judeo-Christian tradition, but rather cyclic. You go so far and then the whole shebang repeats again. Now, yes, in order to do that, what you have to have is the invalidity of the second law of thermodynamics, which says entropy of the universe always stays the same or increases. But if it's going to go back to an earlier time, then it will have to decrease. Therefore, the second law, as Hawking perfectly well knew, has to be thrown out if you're going to avoid, using his technique, the initial singularity. So this is a perfect example of a great physicist throwing out a firmly tested law of physics, the second law of thermodynamics, which Einstein in his autobiography said, this law, the second law of thermodynamics, will never be set aside. It will always be valid in its domain of reference, which is the entire universe. Einstein got it right. Hawking got it wrong. God exists.
And if I understand, even Einstein himself was sometimes subject to errors of this sort. If I'm correct, there's something called the fudge factor, which he introduced into some of his equations, which would allow him
I think you're
to circumvent
cosmological constant.
Yeah, okay.
What Einstein was trying to do is Einstein at that time, alas, alack, wanted to get rid of God too. So what he wanted to do was have the universe eternal, unchanging in the large. Now, he realized that his equations said that the universe has to be either expanding out or contracting in. Experiment would determine which is which, but it could not essentially say the same size. It has to increase or it has to decrease in size. Now, Einstein said, this is not allowed because if it increases, well, there would be a beginning at a finite time ago, as it says in Genesis. We can't allow that. So he put in the cosmological constant for no other justification than to make the universe static. Now, unfortunately, this was not enough because people instantly showed if there's any slight variation in the Einstein static universe, and there is, obviously the density of air is less than the density of me, that is sufficient to make the Einstein static universe cease to be static and start to expand. Oh dear, Einstein's introduction of this fudge factor failed completely, and Einstein, to his credit, said, this was the worst mistake I ever made in my life. Had he not introduced the fudge factor, had he not tried to get rid of this, beginning of time, he would have made a great discovery, the expansion of the universe.
So it would seem that scientists are human and are subject to biases like anybody else. And despite the reputation that that some have for being extremely clinical and following the evidence wherever it goes, I guess in your study of scientific history and your experience, probably there are scientists whose agenda wins out over the science. Is that a fair summary of
that is
of
a
the
fair
situation?
summary, but the good thing is science is indeed progressive. Eventually, everyone will recognize the truth. Eventually, you and I, Rabbi, may not see it in our lifetimes, but eventually scientists will realize that God exists. They have no choice. It's in the mathematics. It's in the observations.
Okay, so let's talk a little bit more about the Omega Point Cosmology, for which you are famous and have been working on for quite some time, which you claim is a proof of God's existence, that it's a mathematical theorem based on the laws of physics and the laws of thermodynamics and relativity, and you claim that it's been confirmed with every experiment to date. And therefore, the only way to reject this idea is to reject empirical science. Could you just explain for our audience what you mean by the Omega Point Cosmology and its significance in your mind to theology?
The Omega Point theology, the Omega Point cosmology, let's start on cosmology and the theology will fall out of the physics, concerns the future history of the universe. Now, when I wrote that book, The Physics of Immortality,
which I recommend.
I made the assumption that life will go on forever in the cosmos. And then I investigated the consequences of that. But due to work of people like Stephen Hawking, a great physicist, if only he would believe his own equations. Using his work, I can now prove what I had to assume in the book. Now, let's see how the laws of physics require life to go on forever to the very end of time. Now, the first thing to note is that Stephen Hawking correctly proved that if a black hole were to exist, there are black holes, we've seen them all over the place, then if the universe were to expand forever, then these black holes would eventually evaporate to completion. And if they were to evaporate to completion, they would violate a fundamental law of physics called unitarity. What unitarity is one way to think about it is conservation of information. Think about it as the quantum mechanical version of determinism. Now, particle physicists told Hawking it's not possible for unitarity to be violated, but Hawking would not go along with that. I think Hawking and the particle physicists are both correct. Hawking showed that if the universe were to expand forever and black holes were to exist, they do, then unitarity would be violated. But the particle physicists were also right. Unitarity is a very fundamental law that cannot be violated. Leonard Susskind at Stanford University proved, after Hawking originally made his claim, that unitarity violation would automatically violate the law of conservation of energy, but in a drastic way, so that if unitarity were violated, anytime you flipped on a light switch, so much energy would be created out of nothing that the Earth would be blown apart. I think we can agree that that doesn't happen. So unitarity, ladies and gentlemen, is a good physical law. But were black holes to evaporate, they would violate unitarity. Conclusion, black holes can't evaporate to conclusion. Now that means, since Hawking also showed if the universe were to expand forever, then unitarity would be violated. Conclusion, what must happen is the universe will expand to a maximum size and then recontract into a final singularity, ending time before any black hole has time to evaporate. This way, you get Hawking's insight and the particle physicist's insight, both correctly integrated, and you see both of these laws, black hole evaporation law, unitarity law, are both good. Now, let's start looking as we're collapsing into the final singularity, what actually happens. The great Israeli physicist Jacob Bekenstein proved that if you go into a singularity and there are what are called event horizons around, then the entropy of the universe has to decrease. But remember what I said earlier. The second law of thermodynamics says very clearly, entropy cannot decrease. Therefore, if the Bekenstein argument is correct, and once again, I've gone through his calculations and Jacob got it right, then the only way out is to say, at the very end of time, as you're going into the final singularity, you cannot have these things called event horizons, which block communication across the universe. Okay, so in the Penrose construction, Penrose is a way of attaching an endpoint to space and time. Now, in the Penrose topology, we call the shape of this final singularity, if there are no event horizons, it has to be a single point. This final singularity has to be a point topology in Penrose's construction. Since it's the very end of time, I'll call this claim, which follows, as I've said, directly from the laws of physics, the Omega point. So what I've described for you is the Omega point theory. And what I have done is I have used just the laws of physics that are in all the textbooks to deduce the existence of this final singularity, which has no event horizons. Now we can look deeper. We can say, how is it that the universe has no event horizons? You use Einstein's theory of gravity, general relativity, near a singularity, and you find out that only if there is intelligent intervention organized across the entire universe is it possible for these event horizons to not exist. So, using the laws of physics, at the final stage, Einstein field equations, we conclude that life must make it all the way into the final singularity, into the omega point. So, we've got life going on forever and a final singularity existing at the end of time, which has the structure of a point in the Penrose topology, using nothing but the known laws of physics that are in the textbooks.
Okay, I'm going to say that that's A, fascinating, and B, despite the fact that I've read the book, is somewhat hard for a layperson to understand, which is fine. I have an easier time understanding what you mean by singularity at the beginning, for whatever reason, as opposed to trying to trace it to the end. However, let me go with that for a moment. I'm going to head and trust that you know what you're talking about, and you've done the research, and there's going to be this singularity. But maybe we could start at the beginning one more time. I know you did mention it. What does it mean to be a singularity exactly? What are the ramifications of that?
A singularity is something intrinsically infinite where the laws of physics do not apply.
Yes, as you said, and therefore it's outside of space and time.
Yes, because anything inside of space and time has to be intrinsically finite.
And would you say it's also uncaused?
Yes. Now, the great mathematician, Sir Edmund Whittaker, who was a fellow of the Royal Society, and won the Copley Medal, that's the highest award given for scientific achievement by the Royal Society. He wrote a fascinating book when I was 1 year old, and as you see, I'm no spring chicken. This was a long time ago, in which he pointed out that the proofs for the existence of God given by St. Thomas Aquinas, the 5 ways, one of which Thomas, I think they all came ultimately from Moses Maimonides in his Guide for the Perplexed, said that what Whittaker said, all of these arguments by Maimonides and Aquinas are what we mathematicians call sequence completion arguments. Now, let's take the second way, the cosmological proof for the existence of God in Guide for the Perplexed. You go through a series of causes. We know we are a result of cause, one of which our parents gave birth to us. Now, their parents gave birth to them and so forth. There is a sequence of causes as you're going back into the past, which lead to us. But the argument was that if you take this sequence, then in the original argument, this led to a cause that was itself not cause. Aquinas and Maimonides argued that could only be a finite number of causes, but we physicists are intimately familiar with a countable infinity of causes. Everything is caused by, has an infinite number of causes from the mathematical standpoint. So we're perfectly happy with an infinite number of causes. So the point is that this infinite sequence of causes going back into the past itself defines a cause which itself has no cause. So the singularity is exactly that. The Penrose topology that I was saying is the same sort of thing. It takes a sequence of points in space-time and uses that sequence to attach a point which has no previous point. So the initial singularity is the uncaused first cause. In the words of Aquinas, all men call that God.
Right. So it's interesting that scientists, cosmologists don't. And I've had the pleasure of, at this point, interviewing quite a number of great physicists, and many of them, when you ask them this question, are willing to go back, it seems, to within a fraction of a second of the Big Bang, and then to say, essentially, what happened right before that, I throw up my hands. I don't know what it was. We have no math for it. We have we have nothing to say about it.
I know.
And therefore, I don't deal with it. And so therefore, they seemed reluctant to draw any conclusions at all. The conclusion that Aquinas apparently did draw, though he didn't have the science. Why is it that we stop just short of the goal, it seems, and they don't say that the singularity is co-equal with a God. They just say maybe it exists and maybe it doesn't, but I have no way of measuring it.
Well, we actually have laws that go back to the initial singularity. Now, as I've said, Hawking proved that classical general relativity necessarily has the universe beginning in an initial singularity. Now, Hawking himself tried to hedge his bet by saying, aha, the singularity will disappear completely when we invoke quantum gravity. But in my papers, I use quantum gravity, one version of quantum gravity, which is called the Wheeler-DeWitt equation. One of my mentors, I was his postdoc, was John Wheeler of Princeton University, a great physicist, the man who introduced the term black hole for those objects out there. Wheeler's people basically made huge contributions to general relativity. So here's a quantum version of general relativity, and I show that singularities are just as existent there too. You can't eliminate the singularity by going to quantum gravity, unless you want to throw out a huge number of other laws too, which is what Stephen Hawking tried to do. And in the end, after throwing away all these laws, he still was not able to construct a consistent quantum theory of gravity, which is different from the Wheeler-DeWitt equation, which actually agrees with experimental observation. I would say that these physicists, I know who you're talking about, and I'm perfectly aware that's exactly what they say. They say it to me, they say it to you, they say it to anybody. They were not willing to use the known laws of physics that are in the textbooks if these known laws of physics imply the existence of God, which they do. Me, I just accept the laws of physics, and if the laws of physics says God exists, well, he does.
Okay, and just to put a point on it again, that business about the fraction of a second before the Big Bang, after the Big Bang, and before that, we just simply can't know anything, true or false. You said there are some equations that do apply to it, but why do they think that?
The equations assert that they apply to any time, no matter how close you are to the initial singularity. Now, if you're familiar with the behavior of physicists, as I am, since I've been in this game almost 50 years, you'll note that when I was coming around, physicists were unwilling even to talk about an evolving universe. That one of the great mistakes which physicists made at the middle of the 20th century was failing to predict the background radiation. Right. I recommend you read a brilliant book by the great physicist Steven Weinberg entitled The First 3 Minutes.
Mm-hmm. I've heard of it.
He has a chapter in there called A Historical Diversion. And he said in that chapter that it is he doesn't use these terms, but I'll use it. It is to the disgrace of the physics community that there was no systematic search for the background radiation, that it was discovered in the end by accident.
Right.
There should have been a search for it because the existence of the background radiation was an automatic consequence of the second law of thermodynamics and the amount of helium and hydrogen in the universe, plus known laws of nuclear physics, which was well worked out by the 1950s. The great physicists, they should have gotten the Nobel. Alas, they were not given the Nobel. Alfred and Herman had predicted the background radiation using these known physical laws in a famous paper in Nature in 1948. But as Weinberg points out, although their physics was correct, their prediction of the temperature of the background radiation was very close to correct. No one looked for this thing. It was easy to find for the easy to use technology, which was available in the late 40s to search and actually detect the background radiation, but no one would do it because no one took the early universe seriously. They thought, the laws of physics don't apply in the first million years of universal history. Then they decided, it applies to the first 400. It applies to the current time up to around 400,000 years. And before 400,000 years, well, we don't know anything. We don't know anything what happened prior to the background radiation. Then finally, physicists got courage because they realized that the structure of the background radiation, which we observe today, had to be formed by processes, physical processes, that occurred earlier than what is called the decoupling time, 400,000 years after the Big Bang. So then they started using the known laws of physics to investigate the earlier history. But although we've got to the first 100 millionth of a second after the Big Bang, most physicists still will not accept the laws of physics even earlier. They're just repeating the same mistake over and over and over again. My claim, guys, let's stop making these mistakes. Let's believe the laws of physics that are in the textbook and see what they imply. Excuse me.
That's okay. There are consequences to beliefs, obviously. That the not accepting reality for what it is or wanting it to be some other way has led to issues, let's say, historically. And there is this concept from your book, Physics of Immortality, which I would like to quote to you, which I think is fascinating. And it has to do with the concept of the eternal return. And in there, you say the following. You say the political consequences of Nietzsche's eternal return philosophy have been catastrophic. Perhaps the simplest way to show this is to point out that the eternal return is sufficiently ancient and important a concept in philosophy and religion to have its own symbol. The old Anglo-Saxon word for the symbol of the eternal return is Vielfalt, if I'm pronouncing that correctly. So dominant had the idea of progress, the antithesis of the eternal return, become in England, that when the English encountered the eternal return symbol again in the 20th century, they had, to their credit, forgotten their ancient word for it. Instead, they used the Sanskrit word for the symbol, swastika.
Unfortunately.
Yes. Could you explain this concept of the eternal return? And does it have anything to do? How could you contrast it with the omega points? And is it a danger in your mind to not embrace the idea of there being a final point to the history of the universe?
I think it is. I think that the idea of the eternal return, I've already mentioned it in another context. I call it cyclic time. And
Right.
Stephen Hawking was trying to create a universe which had cyclic time. Cyclic time is just another word for the eternal return. Now, if you have cyclic time, then what must happen is the progress which we have made with tremendous effort, we humans, over the past 10,000 years, must one day come to an end, and the whole universe collapse into ruin so that the whole thing can begin again and again and again, and time without end. And the ancient Buddhists who believed in the eternal return realized this is horrible. We have to get off of this treadmill of over and over and over again. The only way they could think of it was to achieve nirvana, which is a
Right.
state of non-existence. Now, the Judeo-Christian tradition is quite different. We have a realization that history is real, that what happened in the past will not be repeated again, that all of our notion of progress, all of modern physics really comes out of the notion of linear time, that time is not cyclic, but will go on and on from an initial beginning to an actual end. Now, this means that progress can go on forever. It also means that once intelligent life comes into existence, it need never die out. And I've given you an argument showing the laws of physics require that intelligent life continue without end. One of the fascinating consequences of intelligent life going on forever is that in order to continue forever, their power, their control over resources must grow without limit as you're going into the final singularity. That means their, among other things, their computer capacity must grow without limit. Now, using the Bekenstein bound, which I use all over the place, great physicist, the Israeli physicist Jacob Bekenstein, shows that given sufficient computer power in the far future, it will be possible for beings in the far future to reproduce as an exact simulation. Emulation is the correct term because it's an exact copy, not just an approximate Xerox copy, but an exact copy of the current universe. This being the case, the beings in the far future will have the power to bring us back into existence long after we are dead, never to die again. This automatically follows from the power given, which follows directly from the known laws of physics. So, if you really believe that time is cyclic, then you must necessarily believe that our line of descent is inevitably doomed. All of our children will necessarily die. So I think that the Nazi behavior of the Holocaust fits in well with that. They were after killing everybody, right? They got what, half the Jews in the world? We had to kill a lot more than that. So bad thing, the eternal return.
Because you're saying because their philosophy is who cares anyway. We're doomed. It doesn't. There is no meaning to any of this. What's their thinking that allows them to act the way they did?
I do not care to judge my colleagues' intrinsic thinking. I just don't think they're thinking correctly. Because once you say eternal return, not only Stephen Hawking tried to do that, but currently Roger Penrose, who justifiably won the Nobel Prize for Physics this past December, also has a version of the eternal return. If you know Roger Penrose personally, and I do, there's no more gentle man than Roger Penrose. But he's adopting a philosophy of life that kills everybody, including all of his descendants. I think he's just deluded. He's just not realizing the full implications of what he is assuming. As I've said, if you keep to the known laws of physics, particularly the second law of thermodynamics, you realize time is necessarily linear, and you cannot have a repeat performance of what has already happened. You have no choice but to go on continuing your progress without limit. And so not only will our descendants continue to live forever, but they will have the power one day in the far future to bring us back. So I think that they will be much nicer than we are. That wouldn't be too difficult, I have to admit. But they will realize that all the struggles we made led to them. So since it will require very little of their total resources to bring us back into existence, I think they will bring us back to existence.
Okay. So this is an ancient concept, the idea of resurrection, certainly present in the Judeo-Christian conception, as you've mentioned several times. But you're putting an updated spin on it. Let's say, I don't mean the word spin pejoratively, by saying it's going to be achieved since it's not really specified how it will be achieved, through a massive computer simulation. Is that fair to say?
Emulation is the word I prefer to do because it's an exact copy. Now, I remember in the Jewish tradition, there was a question of how, when you're resurrected, how will you know that it's you that's been resurrected? And one of the explanations in the Jewish tradition I remember hearing was that you will be brought back into existence. If you have a missing leg, you will have that leg missing, so you'll know it's you, after which the leg will be fixed. So the whole point is the question of identity. That's why you prefer to use the word computer emulation. It's more like a backup copy, which you'll make of a document. If you lose the quote original, end quote, you know perfectly well there's no difference between the backup copy and the original. So losing the quote original, if your computer hard disk has a failure, but you've backed it up, big deal. You've got the original, end quotes, document. That captures the idea of an emulation. That's why I prefer to say we will be emulated in the far future. It will be us again.
Okay. There's actually a debate in Judaism as to whether or not the resurrection is a physical one or a spiritual one. And I'm not sure within science and within physics, like how you understand what it means to be spiritual, as it's fundamentally outside of that which is physical. But I did write down a quote that I just wanted to give you quickly from Maimonides on this topic and bounce it off you. And then I do have one other question about what it means to be emulated in a computer. But so it says, Maimonides is of the opinion that the ultimate utopia is a world of utter spirituality. In the world to come, he writes, there are no physical forms or bodies, only souls. And then he goes on, there's no eating and drinking, nothing that a body needs in the present world. So would you say that that's in agreement or disagreement with your conception of the Omega points and what will happen?
Well, as you know, there is a debate amongst Christians and amongst Jews about this, but you have to understand what is meant by body and soul. Now, I'm more familiar with the Christian tradition, but I don't think it deviates enormously from the Jewish tradition. In particular, Maimonides, like St. Thomas Aquinas, was enormously influenced by the Greek philosopher Aristotle.
Yes.
Aristotle defined the soul as the form of activity of the body. Now, in Aristotelian physics, translating the word form, formal cause, Aristotle envisaged 4 basic causes. I would say the best current expression for form, using Aristotle's example, is computer program. So I like that idea. Namely, the mind is really a computer program being run on the hardware, this wit computer inside of our skulls that we call the brain. So in my understanding of spirituality, spirituality refers to the soul, which is to say a computer program. Now, when we are emulated in the computers of the far future, we will be indeed pure soul, a pure computer program. There will, however, be a lower level. We're at a higher level of implementation, is the computer science way of saying this. But inside the emulation, we will be pure soul. We will start out, I think, as a physical embodiment, but then we will move up and indeed transform our bodies so we will not have to eat and drink.
Is it fair to say that a computer program is co-equal with information?
Let me tentatively say yes, because there are subtle differences, and I want to see where you're going with that. I have to invoke the subtle differences.
Well, I'm just thinking that if a soul is information, if it's mind, if it's something that could be backed up, emulated, as you say.
Yes.
It can exist in multiple places, or perhaps even within our lifetime, it exists in multiple places. Because if I compared my own 1-year-old body with my 15-year-old body, with my 45-year-old body, they seem to have nothing to do with each other. And yet somehow the program is running within it, and there's a coherence to the whole experience. So therefore, I like to think of it sometimes as information, like my memories, my experiences are being stored somewhere. Maybe it's the brain, or maybe it's the soul, or maybe a combination of the two. But
I would say your soul is the program being run in your brain. So indeed, it is stored in your soul. But remember, from the Aristotelian point of view, and the view which I'm expressing, most recent person, Steven Pinker, who is a professor of psychology at Harvard, has been making the same point of idea that what's really happening is the mind is basically a computer program, but he makes the mistake in thinking this is material. I like to think about there is a fundamental distinction, even in physics, between hardware and software. We, of course, know that when you bought your hardware, your computer, you also have to buy the apps to actually run on that thing. Otherwise, it's completely useless. Similarly, there is a distinction between the actual brain and the pattern in the brain, which is the soul. And you could see the analog of that in physics itself, because the second law of thermodynamics dictates constraints on patterns in matter. The first law of thermodynamics, basically conservation of energy, deals entirely with material, with matter. So in physics itself, we already have in the laws of physics this distinction between matter and the patterns in matter. I would say materialism deals with matter, patterns in matter, that's the soul, that's spiritualism.
Okay. Well, that should be very encouraging for people if that is the case. It seems, and I think you do emphasize this in your writing and some videos that I've seen, gosh, shouldn't we just rejoice at the notion of the simple possibility that we don't just get snuffed out of reality, and there won't be per se an ultimate heat death of the universe in which everything we know and love and care about is gone. Isn't this the most hopeful idea that could be out there in the scientific world?
I think so. I like to say, if the laws of physics be for us, who can be against us?
That's a good phrase. So I have just one more question on this really interesting discussion, and I encourage everybody who's listening to this, please go out and read the book and think about these matters for yourselves. It's not so often in my casual observation that someone within the scientific, academy is willing to come out and draw some of these conclusions and make some of these points. So to me, it's quite bold. But I've also noticed that it does not seem to be so universally well received. And I'm just wondering how you feel within the academy. How does Tulane feel about all of this? And how do you deal with some of the critiques that are leveled at you? I won't quote them, but I did see one from Lawrence Krauss.
I'm probably familiar with most of them.
I'm sure I saw one from Lawrence Krauss, and one from John Polkinghorne, and they were critiquing these ideas. And do you find that disheartening? Do you think they're just simply mistaken? Do you listen to their criticisms? How do you feel about all that?
Well, generally, I don't listen to their criticisms because I think that the laws of physics are sufficiently clear. That Polkinghorne in particular, since you mentioned it, he doesn't understand general relativity. He is a particle physicist. He does not realize the consequences of general relativity. And so I think it goes back to something you said at the very start of this interview. Namely, many physicists try to be extremely narrow specialists and not apply these laws all over the place. My attitude is these laws of physics in the textbooks, they're in the textbooks because they've been thoroughly tested and we know they're right. And I've done some additional work arguing that people are told there was a huge revolution in the 20th century when classical physics was dumped and replaced with quantum mechanics and relativity. I published a paper in the Proceedings of the National Academy of Sciences, a major scientific journal, in 2014, in which I pointed out that really quantum mechanics is just classical mechanics taken seriously and made fully mathematically consistent. In particular, I pointed out, and I use this phrase in the paper, Einstein got it right. God does not play dice with the universe. The whole thing is totally deterministic, nice and classical. The same thing is true from relativity. I published a few papers on that too, that general relativity is not really different from Newtonian gravity theory. So I'm fairly confident, actually strongly, let me use a stronger word. I'm very confident that we can trust these laws of physics because they are essentially unchanged for hundreds of years. And all that we've happened is got a little bit sharper on the consequences. All I'm doing is drawing the mathematical consequences of the laws of physics. And you yourself pointed out that my opponents will simply refuse to apply the laws of physics in really early times. And they followed this strategy over decades, if not a century, and they always get the wrong answer. They won't apply the known laws of physics. When you do, you see that you can explain all these phenomena. And when you do, you see that God exists. He's just an automatic consequence of the known laws of physics.
Wonderful. Dr. Tipler, thank you so much for being on Beyond Belief. It's been a real pleasure. Can I come visit you in New Orleans if I'm ever down there?
Sure. Give me a call and we'll have lunch together.
All right, that'd be awesome. And thank you so much for being here and for your ideas. I encourage people to go out and look at some of his books and study it on your own. But please, for the moment, please subscribe to our YouTube channel and stay abreast of all the great things that we have happening here at Aish. And wishing you a good day and a good evening. All the best. Bye-bye.